Hello, students. So, fun fact, aka funny story, this is the second time I'm attempting to record this lecture. So I went through the whole first one. It was like 35 minutes long, and it wasn't recording. So this is take 2 for Miss Williams, take 1 for you. So hopefully you just watched the natural resources lecture. Now we're going to talk about greenhouse gas, or the greenhouse effect. So whenever you hear the greenhouse effect, most people normally think it's a bad thing. In some aspects, the greenhouse effect isn't good, but the greenhouse effect is how we stay warm. So again, go ahead and make sure your Chromebook is on split screen, so you have your Word doc with the notes that you can fill in, and then me doing the video on the other side, just so it makes your life easier. Unless you have 2 devices, and then you don't have to worry about split screen. So let's go and start this presentation. All right, so greenhouse effect is how we stay warm. We've kind of already talked about this a little bit whenever we were in space talking about the sun and our planet. So the sun's energy reaches Earth through radiation. Radiation is heat traveling through space. So that's going to be your first blank. The sun's energy reaches Earth through radiation. That's all you need to write in there is radiation. All right, so what is insulation? Insulation, not to be confused with the insulation up in your attic, kind of does the same thing though. So insolation is the incoming solar radiation that reaches the Earth. So the radiation from the sun that hits us is insolation. That's going to be your first blank there. So insolation is the incoming solar radiation. The most intense time for insolation is at noon, on the summer solstice, near the equator. And it's near the equator because the equator gets the most direct sunlight. So we've seen this image before, especially whenever we were talking about weather, and also whenever we were in our space unit. The most direct sunlight is at the equator, right here. And then as you get further away from the equator, the less direct or the more diffused that sunlight is. So how much solar radiation reaches the Earth? Only around 51% of all incoming solar radiation reaches our surface. 30% is automatically reflected back into the atmosphere, or not the atmosphere, into space, because it hits it, immediately reflected off. And like we said, 51% reaches the Earth's surface and is absorbed by the Earth, and then 19% is absorbed by the atmosphere, so it gets caught up in the atmosphere. So in that blank there, the Earth's atmosphere, or the Earth's surface only absorbs 51%. So, the heat budget, or the energy budget. Energy is transferred from the Earth's surface by radiation, conduction, convection, evaporation, and water condensation. So ultimately, the sun's heat and Earth's energy transfer is what causes more extreme weather. So in your notes there, it's going to say ultimately the sun's heat and energy's transfer is a major cause of weather. And again, weather is what happens on the day-to-day basis. Climate is going to be the overall long-term weather pattern. So that blank for that one is a major cause of weather. So the greenhouse effect. So the definition of this is that it is the process by which atmospheric gases absorb heat energy from the sun and prevent heat from leaving our atmosphere. In other words, greenhouse gases trap heat energy and keep it close to Earth. The 3 main greenhouse gases are carbon dioxide, methane, and water vapor. And we'll talk all about these 3 more in a moment. But in your notes right there, you can fill in the greenhouse effect is the process, and then you'll write all this. And then, in other words, greenhouse gases trap heat energy. That pink word goes in that blank. And then this is going to be the next 3 blanks: carbon dioxide, methane, and water vapor. That's just another picture. So the greenhouse effect kind of works how a greenhouse for your plants work. So you will have the visible energy or the sunlight coming in, and then it's either going to be reflected back or it gets trapped inside of the greenhouse. And that's kind of how our atmosphere works. Our atmosphere works as a greenhouse. So, is the greenhouse good or bad? On your notes here, you have a picture, and then you have explain the greenhouse in your own words, or the greenhouse effect in your own words, and then I want you to write a question. So, on your notes, you can do that part. Explain to me what the greenhouse effect is. You don't necessarily use the definition word for word, but kind of put it in your own language. And then if you still have a question about the greenhouse effect, you can put that there as well. If it's like a really serious question that you really want an answer to, just email it to me or comment on this material, and we can do it that way. So, the greenhouse effect, like I stated in the beginning. Is it good? Is it bad? Is it both? It is kind of both. So, we have to have the greenhouse effect in order for us to exist. It's necessary for life. So, it keeps our climate nice and warm, and it prevents it from fluctuating too much. So, as it gets hotter, you would have more extremes, like hotter hots, colder colds. But the current temperature, it keeps us at a good average, so the extremes don't swing as much, if that makes sense. Now, most people hear the greenhouse effect as a bad thing, because that's kind of how we talk about it whenever we speak about climate change or global warming, and the greenhouse effect comes up. It's always kind of looked at in a bad light. So the greenhouse effect can be bad, but only whenever we have too many greenhouse gases in the atmosphere. Because once we have an increase in the greenhouse gases, we will then also have an increase in global temperature. And that's where you get global warming from. So we kind of talked about Venus a little bit in our space unit. We talked about how it has a very thick gaseous atmosphere, and there's most likely a lot of greenhouse gases on there. So therefore, that planet is very hot. As opposed to Mercury, it really doesn't have any type of atmosphere. So if it doesn't have an atmosphere, that means there's not greenhouse gases there to keep it warm on the surface necessarily. I mean, the planet itself is hot because it's closest to the sun, but there's really no atmosphere to kind of keep it hot like Venus. So what is global warming? This is going to be right there in your notes on number 6, I believe. Global warming is an increase in average global temperatures. That's going to be your first blank. And then it's caused by an increase in greenhouse gases. That is your next blank. Caused by an increase. So, what causes these increases in greenhouse gases? There's a couple different things that cause the increase. We, as a species, kind of initiate a good majority of these. But in other cases, some of these reasons are natural. They happen without us. So the first one is carbon dioxide being added to the atmosphere. This happens whenever we burn coal, oil, gasoline, natural gas, or any of the fossil fuels. Whenever we burn those, we're typically using them for transportation, factories, electricity. But the burning of these fossil fuels adds carbon dioxide, which we already know is a greenhouse gas, to the atmosphere. So in your notes right there, you will have carbon dioxide is added to the atmosphere whenever we burn coal, oil, and natural gas. And then in parentheses right there, you will put fossil fuels. So the next thing is deforestation. Deforestation is going to be your first blank right there, or the clearing of forest, also increases the amount of carbon dioxide in the air because in photosynthesis, plants take in carbon dioxide, remove it from the atmosphere, and make oxygen. So, typically, we rely on our plants to counteract the first thing we just talked about. But if we take away the plants, the carbon dioxide is then not being pulled out of the atmosphere. So since it's not being pulled out of the atmosphere, it's just going to continue to accumulate, and also without the plants. So because of deforestation, we are getting a lower input of oxygen. So we have less oxygen to breathe whenever deforestation happens. So that's two bad things. We got more greenhouse gases in the atmosphere, then we've got less oxygen to breathe. So we need the plants. The next one are mostly natural causes. Volcanoes naturally put CO2 and other gases in the atmosphere. Fires naturally put CO2 and other gases. And then respiration adds CO2. And respiration is just a fancy word for breathing. But fires can also kind of be man-made, but they do occur naturally as well. So all of these also cause an increase in greenhouse gases. And you'll see those right there, number 3 on your notes. And then number 4, methane. So methane is produced whenever garbage is buried in landfills and from animal waste, and then also natural resources. So for landfills, whenever we try to cover them up, it's necessary that we put like an escape pipe kind of situation going on, because once all that trash is covered up and it starts to decompose, it produces methane. Really what happens is there's bacteria that eats the decomposing stuff and then they produce the methane. But if you don't have an escape for that methane, it could blow up your landfill. Normally you'll see the pipes with a flame on them. That's methane gas burning off. And then, of course, animals, they produce methane with their waste or their poop, and then also just the gases they pass. So cows, us, all the other animals. And then there's another source that methane gas comes from. So in the oceans, most of the ocean, or not most, the organisms or environments in the ocean are very dependent upon temperature and pressure. So, and whenever we're talking about methane deposits underneath the sea floor, they are very sensitive to temperature changes, just like coral reefs would be. So what happens is, as the global oceanic temperature rises, and it normally rises due to atmospheric temperature rises, so once they rise, that is then not a favorable environment for methane deposits in the ocean. So then they will thaw and turn into a gas and bubble up and return to the atmosphere. So whenever the global climate increases the oceanic temperature, it is then going to be releasing methane deposits from the bottom of the ocean, which was safely stored under the oceanic floor until the temperature increase happened. So it's all interconnected. So the next one. This one's pretty, this one should be almost common knowledge if you're pretty good at understanding the water cycle. So this is going to be number 5 in your notes. So as temperatures increase, evaporation then increases. And whenever evaporation increases, that's putting water vapor into the air. And as we saw on an earlier slide, water vapor is a greenhouse gas. So, it gets hotter, more evaporation, more water vapor, increase in the greenhouse effect. So you can kind of see that here. We're going to kind of answer these questions together on these next few slides. So here we see a graph that's telling us the year down here, and then the temperature change over here. So how much have global temperatures changed between 1980 and 2000? So you can't really see down here, but 1980, well, 2000's here. So we'll say like 1980. Oh, sorry. Let's see if that little black thing goes away. Yeah, I still can't see. So we're going to say like 1980s right here. I have something blocking it. So 2000, 1980, it's going to be about a 0.5 temperature change. So 0.5 degrees Celsius is going to be your blank for question 1. Then we move on to question 2. How much are global temperatures expected to change between 2000, which is here, and 2100? So we could go with this blue line because these different lines are different projections, but let's go with the blue line. That puts us at about a 5-degree temperature change from almost 0 to that number. So for number 2, I would put 5 degrees Celsius. So that's a big increase for the projection. Projections have changed as we've gathered more data, but it's still at a very unsustainable increase. So, is global warming melting the ice caps? We can see here that in 1979, the Arctic ice sheet was mapped out. As we can see in this picture, there is not that much ice there. So, whenever this picture was taken, the polar ice cap had melted away by 20%. That's a lot of ice. That was a lot of ice to lose. And you can tell that it's still thawing out and it's getting thinner and thinner. So for question 3, you need to put in 20% of the polar ice cap. So the next thing concerning greenhouse effect is sea level rising. Well, you tell me, if you've ever heard of people owning property on the coast, their houses are getting washed away during storms or just in general. The sea level in general is rising. But if we look here, we want to know how much the sea level has gone up. So the question says since 1990. Right here is 1994, so we're just going to say the end of this graph over here was the sea level. So 0 is sea level whenever we talk about elevation. So sea level right here, 1900s. And since it says since 1990, we're going to go all the way to the end of the graph. So we go from 0, and if we stay on this line of best fit here, this black line, it's going to be right at 40. So we also need to find the unit. The unit down here is millimeters. So in this time span, sea level has risen 40 millimeters. So that's going to be your answer for number 4 is 40 millimeters. So the next thing, is global warming causing stronger storms? We know that hurricanes get strength from warm ocean water. So as the climate warms, your ocean water and your ocean currents are also going to be warmer. And this means they are putting more warm water vapor into the air. And since there's more warm water to feed the hurricane is getting stronger. So, number 5, hurricanes is your first blank, get their strength from warm ocean water. So as temperatures increase, we should expect more intense storms. Yes, that's correct. Because more warm air means more warm water, means stronger storms. So, yes, we should expect stronger storms. All right, so we've seen a lot of images that kind of look like this. Just choose 2. You've got your deforestation. There's one thing that we didn't really talk about was chlorofluorocarbons. That comes from aerosols, and that's kind of more like back in the day whenever people used hairspray all the time, that released a lot of chlorofluorocarbons. Chlorofluorocarbons. That's a hard word to say. It's kind of fun, but it's a little hard. So you could choose one of those, or of course in our cars, and then radiation and nuclear power plants and things like that. So just choose 2 of those and put that in your notes. Sorry. And then number 7. So we should know this answer from the meteorology unit and from the space unit. Where is the Earth the warmest at? This is going to be where it gets the most direct sunlight. So that will be at the equator. As you can kind of see here with the temperature gradient, the warmest stuff is going to be at the equator. And why? Because it has the most direct sunlight. And here's just another picture talking about how the polar ice cap is decreasing. Yeah, so as temperatures increase, the ice melts, sea levels rise, ice caps shrink. That's how that works. And then again, just another image explaining the greenhouse effect. We get the solar radiation from the sun. Part of it gets down to the surface and is absorbed or reflected. Part of it gets lost in the atmosphere because of all the little particles. And then part of it is automatically reflected off the atmosphere. So it doesn't even come into our system. So, yeah, that's the rundown of the greenhouse effect. It ties into global warming. And whenever we hear global warming, we're like, global warming. There are things that tell us that our Earth does go through cooling and warming periods. But whenever we talk about global warming, it's the fact that in this moment of Earth's history, we are exponentially warming the climate much faster than any natural occurrence in our Earth's history. So something's happening that is making it happen faster. And as we went through the greenhouse effect, whenever more greenhouse gases get put into the atmosphere, the Earth gets warmer, storms get stronger, ice caps get smaller, sea level rises. And that has so many implications for how we as a species live our life on the planet. So is the greenhouse effect bad? No, because it makes us be able to live here. Now, increase in greenhouse gases can make the greenhouse effect be a bad thing. So be on the lookout for the next videos. If you have any questions, please email me. And hope y'all have a great weekend. Make sure you're looking at stuff in Google Classroom and email me if you have questions. See you later, guys.